AWS Backup is an interesting service that often gets overlooked because how uncool backing up data is in technical discourse. Backing up is not a direct functional feature for most products and architectures, and even when it is discussed, most of the time it's done so as a checkbox marking exercise rather than going through the full measures. So what is AWS Backup? Simply said, it's a single point in the AWS organization to control how data should be backed up and retained for a long list of AWS services. This could be storage services like S3 or EFS, or databases like RDS or DynamoDB, or certain other services that have direct integration with AWS Backup. You might ask why a separate service is needed when each of these AWS services have features to back up data independently. Well, I have just the answer for you. Before I dive into that, welcome to my channel. I make videos on cloud, mostly AWS topics. Please subscribe, like, and share the video if this content helps you. Back to the topic. So like I mentioned in the introduction, different services have features to back up data on their own. However, using those features entirely depend on how the product or the solution is designed and implemented. Just depending on those features being used is going to be a brittle approach for a system-wide backup strategy. Also, the architecture demands of system-wide backup parameters have to be enforced on each of the services. If you depend on each service features alone, that's going to be a lot of places that can go wrong at the same time. Also, as someone who's responsible for answering for the product or the solution, you'll have to dig through multiple service configurations to find out if backup jobs have been successful or not, if they are correctly configured, and if they are correctly encrypted and retained, and so on. This is going to be too much work, especially if your architecture is a bit more than a simple auto-scaling group behind an ALB kind of one. This is why AWS Backup exists. It's a single control plane to implement a consistent backup strategy across the entire AWS organization if needed. AWS Backup allows you to configure backup plans and then associate different resources with those backup plans. This way, each resource can be part of a multi-layered backup strategy without having to configure individual services. So what are some of the features that you should be aware of in AWS Backup? Number one is backup vaults. AWS Backup centers around a backup vault. A vault is just what it sounds like, a central place to store backed up data. There is nothing much more to say about vaults. Basically, we'll check out the features like retention periods and encryption in the demo. The next important feature is called backup plans. A backup plan can be considered as a template for part of a backup job. It defines the details like backup job frequencies and how long backed up data should be retained. A plan doesn't include the resources to be backed up directly. Rather, the resources are associated with one or more plans as needed. This provides a healthy decoupling between the backup plan, the backup strategy, and the resources that are being backed up. So a single resource, say an S3 bucket, could be part of multiple backup plans that handle multiple frequencies and retention periods. You could also have the data being backed up copied to multiple vaults. This way you could ensure that even if a single backup vault is deleted accidentally, let's say, you can still restore your data. This could especially be useful if you use a cross-account backup vault that can be used as a break glass backup vault to restore from. Now let's take a look at a simple demo scenario. In this case, I have two accounts in an organization. One is an account that has some production workload. This workload has an RDS instance and a DynamoDB instance. The plan is to back up data from both these sources into a backup vault. I also have a separate backup account with a backup vault that I'm going to use as a cross-account vault. This kind of a separate backup account is a typical structure you'd get if you deploy an AWS landing zone with Control Tower in your AWS organization. I have written two Terraform modules to be deployed to the two accounts. The first module called Central is going to be deployed onto the separate backup account. I'm going to need some details from this deployment to continue deploying the resources in the workload account. I'll deploy the Terraform resources now. If you're trying this code out and if you get an error saying the AWS service role for backup doesn't exist, Go to AWS Backup in the web console and create a test backup plan that can be deleted later. Service-linked roles are usually created on first interaction with the service or the account, especially if the account is a fresh one. Before I can deploy the resources in the workload account, I'm going to need the cross-account vault ARN for obvious reasons. That's because I'm going to use that ARN in the backup plans that I'm going to create in the workload account. I'm also going to need the ARN of the AWS Backup service-linked role for encryption purposes in cross-account backup vault use case. Now bear with me because this is going to need some in-depth explanation. So when it comes to encryption, AWS Backup has basically two modes for data that are being backed up. For some services, it supports what is called independent encryption, where the data is encrypted with KMS key attached to the destination backup vault. This is called independent encryption because encryption is independent of the service-specific encryption configuration that is used. Now, DynamoDB is a service that supports independent encryption. So in independent encryption, AWS Backup handles encryption of the data completely, so resource policies and key policies don't have to be modified. Note that DynamoDB support for independent encryption is only available by default if the AWS account in question was created after November 21st, 2021. If your account is older than that date, you might have to go into AWS organization and enable advanced DynamoDB backup feature separately. Refer to the documentation if you have any doubts on this. For services like RDS that do not support independent encryption, AWS Backup uses the KMS key associated with the resource to perform encryption and decryption of the backed up data in the source account. In cross-account backup scenario, in the source account, these actions are performed by AWS Backup job role, the ones that are specified when creating the backup plan. In the destination account, which is the account that has the cross-account backup vault, the AWS Backup service linked role, which is called AWS service role for backup, is used to copy the backup data across the accounts. So these roles have to be provided encryption and decryption permissions in the resource-specific KMS key policy. The job role needs encrypt and decrypt permissions, and the AWS Backup service linked role from the destination account needs decrypt permissions because it needs to decrypt the data, then copy the data over and re-encrypt with the KMS key associated with the backup vault in the destination account. So it goes without saying you should use KMS CMK keys as opposed to service managed KMS keys because you need to be able to modify the key policies of these encryption keys. Now CMK here means customer master key, but it looks like AWS is phasing out that term. So in general, if you hear KMS key, that usually means customer managed KMS keys. Right, now that we have that specific detail out of the way, let's deploy the resources in the workload account. In the workload account, I have a backup vault, a backup plan that backs up data with an hourly frequency and retains those data for 30 days. The backup plan also copies the data across to the central backup vault and keeps them there also for 30 days. I have attached both the RDS instance and the DynamoDB table to these backup plans. It doesn't have to be two separate plans. I just wanted to demonstrate multiple plans here, but it could have easily been a single backup plan with multiple types of resources attached to it. Note that I also create custom roles with AWS managed policies for backup and restore, but I don't really have to do that. There are default roles that are being created when you first interact with AWS Backup. Now after some time, I can see the backup being created in the source vault and then being copied over to the cross-account vault. I didn't really need to work with the RDS or DynamoDB backup features to get this working, and with some minor modifications I can have any resource that is created in the future to be associated with this backup plan too. Now in this demonstration I directly attached the resources into a backup plan, but you can also attach resources by a tag selector. That way I don't really need to worry about how backup is implemented if the environment is let's say too dynamic, too many resources being created, and I just have to maintain the proper backup plan, the backup strategy, and then let AWS Backup do its job. I'm going to complete this by destroying the resources to save some dollars, and if you follow this you should do that too. Just a note, in a real world situation you should almost always never delete a backup vault. That's a real no-no, a career limiting move. And in fact, if the backup vault is not empty, you can't delete it without emptying the data that has been backed up first. Just like an S3 bucket, you have to manually delete those restore points, recovery points first. So I'm going to remove those recovery points manually and then run Terraform destroy to finish. So that's a brief demonstration of what AWS Backup can do in general. There are some new features that have been introduced around the time of 2023 reInvent. I'll explore those ones like recovery testing in a future video. All the code that I worked with in this video is available in a GitHub repository that I'll include in the description. Thank you so much for watching. I'll see you next week.